Okay, we're going to have a look at compass directions and bearings, guys and gals. This is a nice straightforward topic, so let's have a look at it. We know that a bearing can be expressed as either a true bearing or a compass direction, okay? And when we refer to these bearings, we're referring to the direction of one object from a reference point when looked at, say, on a map from above, okay, like you were looking, as if you were looking at a map, okay. Now, compass directions. A compass direction, basically, these are directions measured from the north or the south line in either a clockwise or an anti-clockwise direction. Now, in order to identify a compass direction of an object, we need to state firstly whether the angle we're measuring is from a north line or from a south line in terms of direction, okay? In terms of direction. Then we need to specify the size of the angle that we are sweeping through from either the north line or from the south line in terms of their direction. And then we need to thirdly specify whether the angle is measured in either the westerly direction from the north-south line or in an easterly direction from the north-south line. If I draw you a little picture here, I think you will understand more clearly how this goes. For example, you see this compass direction south and 20 degrees east means that the direction is 20 degrees from the south, the direction from the south, then towards the east by 20 degrees. So having a look, we're measuring it from a reference point of the southerly direction, and then we're moving 20 degrees to the east, okay? And that's that away. All right, now, whereas this one here, we would naturally start from the north, from the northerly direction here, because in order to, for example, if we wanted to use the southerly reference point as our starting direction, then we'd have to basically sweep through 140 degrees to get to this line here, pointing to our object of interest, which would be a much bigger angle than 40 degrees. So we choose the direction which gives us a smaller angle of the two. So in this particular diagram, we start from the north or the south, but in this case the north, and then we move 40 degrees to the west, which is that away. Okay? So in summary, this is south, 20 degrees to the east, like that. This one is north, 40 degrees to the west, like that. How are you going to get that? They are compass directions. But now we're going to look at true bearings, okay? That's the other way of referring to the same thing. True bearings are measured from a north in a clockwise direction. They're measured from the north in a clockwise direction. They are always expressed in 3 digits. The number is always in 3 digits. The diagram below shows bearings, true bearings that is, of 25 degrees true and 250 degrees true respectively. This one here is our 25 degrees true. This one here is our 250 degrees true. These are true bearings which would be commonly written as 025 degrees with a capital T, or 250 degrees with a capital T. You'll notice that they're always done clockwise from the north direction as our starting reference direction, okay? So always from the north line here in terms of a direction. So this one sweeps through 25 degrees to get to this line here, this direction line, to our object of interest. This one here, on the other hand, sweeps through 90, 180, and then another 70 degrees here to make a total angular sweep from the 12 o'clock position of 250 degrees to get to the direction that our object of interest is in relation to our reference point, okay, from which we are taking our bearing. Okay, how's that? Very good. Let's do some examples now. Alright, we've got a boat travelling a distance of 5 kilometres from P to Q in a direction of 035 degrees true. Okay, how far east of P is Q and how far north of P is Q, and what is the true bearing of P from Q. That word from is very important. That means from Q as our ground zero, our reference point. Okay? Yes, and that's the one we always draw our perpendicular compass reference lines through, the from, when we're working out bearings. But let's just not get too ahead of ourselves. Let's do A and B first, alright? So, here's the diagram. You always draw a diagram, guys, always, so that you know clearly what you're dealing with. So, okay, we went on a bearing of 35 degrees true. That's from the 12 o'clock in a clockwise rotation. That's 35 degrees. Therefore, and this line here, we went 5 kilometres, right, from P to Q in that direction, defined by that 035 degrees true. Alright? Now what we've got to do is work out how far east is Q from P. Well, there's Q, there's P. This line here, this horizontal line here, over towards the east is how far east Q is from P, and this line here, if you like, this R to Q, the length of that line is the vertically up component of its change in position from P to get to Q, and that is how far north it is, Q is from P. Alright, so let's do the first bit. We want the east bit first. That's PR, as I was explaining. So therefore, using basic trigonometry in this little triangle here, where I've got the dotted lines here, triangle PRQ, alright, triangle PRQ. We know that cos 55 degrees is PR over 5, and therefore PR, by rearranging that, would be 5 cos 55, which comes to 2.87 kilometres to 2 decimal places. Therefore, we can write in words that Q is 2.87 kilometres to the east of P. Okay? Now, in part B, as I said, we're now interested in the length of RQ, because that's the vertical translation of Q in relation to P. In other words, the northerly translation of Q from P. So therefore, in that triangle, in that same triangle PRQ, we can say that sine 55 on this occasion, which because we want this opposite side, so that's equal to QR over 5, and therefore, similarly as we did up here, we can then rearrange that little equation there to get that QR is 5 sine 55, which comes to 4.10. Therefore, we can write in words that Q is 4.10 kilometres to the north of P. Okay? How's that? Yeah? I think it's pretty straightforward, don't you? But you've just got to get your ducks in a row and understand how these bearings work. Now, part C is a little bit more complicated, so here's a diagram. Now, we've moved from P to Q, as you know, on a bearing of 035 degrees true, and we're at Q. But what they're asking us for in this section, guys and gals, is what is the true bearing of P looking back from Q. Now, that word from is where you put your compass perpendicular lines as around that point, because that is your reference point now, from which you are looking to find P. Okay? So really what we want is the angle all the way from the 12 o'clock at Q all the way down here in a clockwise direction, all around there to that black line, which is our line of sight back from Q to P. Okay? So what I would do there, guys, yes, that is a 35 degree angle. That's the first thing to work out, okay, because you've got a right angle triangle here, and because this one at R is already a right angle, these two must add up to 90 degrees by themselves, plus then you get the other plus 90 to get to 180. So therefore, that's a crucial little bit of geometry there to work out that this angle in here, this PQR, is 35 degrees, okay? Now, okay, yes, you put the compass lines around the from location, which was Q in that case, and we know that angle PQR is 35 degrees because the sum of the angles in that triangle PRQ is 180 degrees, and hence the true bearing, guys, of P from Q is, as I said, all the way around here. That's 90 plus another 90 plus this 35 to get before we hit that black directional line from Q, line of sight back to P. So that would be 180 plus 35, which would be 215 degrees true bearing. Okay? How was that? Yeah, it's pretty straightforward. But as I say, you do have to get your ducks in a row to know what you're doing with this stuff. Alright, now, sometimes a person or an object, for example a ship, changes direction during its journey. This can even happen more than once. Perish the thought. In situations like this, we are usually interested in the total distance the object has moved and its final bearing from its starting point. Okay, two stage ones in other words, guys. The following work example shows how to deal with this situation. You just draw diagrams and keep your head and make sure you just stay cool, step by step, inch by inch, everything's a cinch, alright? So what we've got here is a boy walks 2 kilometres on a true bearing of 90 degrees, that's true, and then 3 kilometres on a true bearing of 130 degrees, alright? So in part A, how far east of the starting point is the boy at the completion of his walk? Answer to 1 decimal place. How far south of the starting point is the boy at the completion of his walk? Answer to 1 decimal place. Now, I've done 2 decimal places just to make it a bit more accurate, so please forgive me, I just don't like 1 decimal place. But in an exam setting, you would certainly do what they ask, okay? What is the bearing of that boy from the starting point in degrees and minutes at the completion of his walk? Okay. At the completion of his walk. Well, let's just take it step by step, bite by bite. That's there's the 2 kilometres that he walked on a bearing of 90 degrees from his starting point, right? That angle there, taken from 12 o'clock, is a 90 degree angle. 2 kilometres walked, in other words, directly east, if you like. Then he walked from that point. He then walked on a bearing of 130 degrees. So therefore that's 90 plus another 40. Okay, but you make sure you put your compass lines around this new point from which he walked. Okay, and that's a 3 kilometre long walk in that direction there, along that line of sight, if you like, from this point here. Right, that basically gives us the picture. Now in part A, we'll basically just make it a bit more mathsy and define a few things so we can refer to them as we go. So this journey here will be OA, this journey here will be AB, and this reference point here in the right angle triangle ABC can be point C. Okay, we've got this angle is 40 degrees, that's 3, that's 2. Okay, I think we're ready to go, ready to roll. So we need, in the first question, OA plus AC. Alright? OA plus AC. They're both basically easterly directions. OA plus AC would get us how far east he is of his starting point at the completion of his walk. Alright? So therefore we can say we already know OA because that's just 2, so we better get AC. In the right angle triangle ACB, guys, alright, we can say that cos of 40 equals AC over 3, alright, and therefore by rearranging that, AC is 3 cos 40, which is 2.3 kilometres, 2.30 I've quoted it, and therefore OA plus AC would be 2 plus 2.30, which would be 4.30 kilometres to the east. So therefore the boy is 4.30 kilometres east of his starting point. I've worked it out to 2 decimals, as I say, but just don't get too hung up about that. Just give them the number of decimals that they ask for, okay? But I actually got a different answer at the end because I used two decimals instead of the 1 decimal stated into here in this question compared to the answer that was given for the question to 1 decimal place by the text. So it does make a big difference. You don't want to be rounding things off too much. Alright, so getting back to this, the boy is 4.30 kilometres east of his starting point at the completion of his journey. Alright, part B. Now, how far south of his starting point is the boy at the completion of his walk? Well, similarly, we can say that we need C to B, right? C to B, that's the southerly bit, right? The southerly component of where he ends up compared to his reference point here, which was where he started, all right? So therefore, in the same triangle, right-angled triangle ACB, we know that sine of 40 on this occasion equals CB over 3. Therefore, CB would be 3 sine 40 degrees, which is 1.93 kilometres. And therefore, we know that the boy, in words, we can say the boy is 1.93 kilometres south of his starting point. Okay? All right, we've got A and B done now, guys. This is beautiful. And now we've got to just do the grand finale of part C. Over the screen we go, and let's knock them out, okay? All right, well, that looks all right. Now, what do we need? What do we need, guys? You think about that. What do we need? What is the bearing of the boy from the starting point in degrees and minutes at the completion of his walk? Well, that there, see? Here's where he started. That's right. That's his reference point. Now, his bearing is going to be 90 down to there, and plus this little angle, this purple angle theta, which I've drawn in here, because that is the line of sight of where he finished up compared to where he started, all right? And the direction is clockwise from north right round to there. So if I can get theta and add 90 to it, I'm laughing, guys, okay? And the key to that basically is that in triangle, I mean OCB, all right? O to C to B, all right? That's a right angle triangle because that's a right angle. Now, I already know that this length here is whatever it was from part A, and this length here was whatever it was from part B. I can just use tan. I can use tan to work out what this little angle in here is, this little purple theta. So therefore theta, as I say, is the angle whose tan is CB over OC, which, here come the numbers, 1.93 over 4.30, and therefore that gets us a 24.17 degree angle. But be very careful, we're asked for the angle in degrees and minutes. So we've got to take the decimal bit, the decimal leftover fractional bit of the degree here, beyond 24 degrees, and multiply that by 60 to convert that fraction of an angle into minutes. And I guess we'll quote it to the nearest minute, all right? So that the true bearing of B from the zero, or the origin, the origin starting point here would be 90 plus the 24.17, which would be 114.17 degrees. Now, if you take the 0.17 and multiply that by 60, you'll get 10 point something, which is 10 minutes to the nearest minute, all right? Now, just to let you know, to finish this off, how important it is not to round things off too hastily. Basically, guys, the textbook solution to this, where you quoted the answer to CB and to OC, the easterly direction, the easterly distance from his starting point and the southerly distance from his starting point in parts A and B, the answer that was quoted was 113 degrees and 50 minutes. So it does make a difference. So don't go rounding things off too hastily. It's a common mistake of students, and you can come very unstuck doing it, okay? So let that be very illustrative for you. I did it to 2 decimal places. I got quite a different answer, okay? So there you go. Now, all right, let's finish off now with our remember stuff. And, okay, we know it all, but we're just going to reiterate it, okay? To identify the compass direction of an object, we need to state in this order whether the angle is measured from a northerly direction or a southerly direction. That's the first thing. And then the size of the angle from there, and whether that angle is measured in the direction of west or from east, relative to our northerly or our southerly starting direction, right? Okay. Secondly, true bearings are measured from north, always from the 12 o'clock, from north in a clockwise direction, and they're expressed as 3 digits with a capital T after them. Yes, and thirdly, when solving problems involving bearings or compass directions, always draw a clear diagram prior to attempting the problem. And just another one from me, look for that word from. The from means that's the reference point, that's ground zero around which you have to draw your perpendicular compass lines and their respective directions. Alright, that's good. Yes, thumbs up to us. We've done a great job, I think. And I hope you'll go and do some practice and get good at these so that you'll get plenty of confidence and you won't be overloading your working memory when you get into a test situation, and you'll do really well as a result. Okay, all the best to you, and we'll see you next time.